Today we are going to start a discussion on signals and systems. So the chapter is 5th of GTU University syllabus. The name Z Transform. So let us discuss what do you mean by Z transform. So very first we will consider the what do you mean by transform. So signal in transform domain or the in time domain, the x of n or x of t. So x of n represents the discrete time signal and x of t represents continuous time signal. The both signal in the transform domain, say we are using transform, say x transform, as over here z transform. So the transform or after transform, the next domain is nothing but frequency domain. It means my x of n discrete time sequence or discrete time signal, that signal in time domain which is now converted into transform domain, that is frequency domain, by any transform. It is the general definition of transform. Over here we are going to discuss Z transform. It means the x of n is then converted after transform, say Z transform, in x of z. So the x of z is the Z transform x of n, and this both is true, that x of z inverse Z transform means convert back to frequency domain to time domain. It is inverse Z transform known as IZT. So x of z is inverse Z transform x of n. So from x of z we can calculate x of n by using inverse Z transform. So let us discuss the whole scenario of Z transform. So the very first thing, it is applicable to discrete time sequence only. We do not apply the Z transform on continuous time sequence or continuous time signal. So the x of n is a discrete time sequence. So Z transform can be defined as the x of z, which is the function of z, is equal to summation n equal to minus infinite to infinite the x of n multiplied with z raised to minus n. That is the standard definition of Z transform, summation x of n and z raised to minus n. So this z parameter, that's why the transform known as Z transform. So x of n Z transform x of z can be calculated by the summation of x of n into z raised to minus n with limit minus infinite to infinite. It means the x of n is evaluated from minus infinite limit to plus infinite limit in time domain. But this time domain is discrete, that is n. N is the representation of time domain, that is a discrete time domain. So n represents the time domain is discrete. It means the signal is in sample form like this. Okay, so if it is t, so t is what? Continuous time. It means the continuous time is like this. This is for example. So we should not forget the n represents the discrete time sequence and the Z transform definition is this. So let us discuss how the Z transform is defined like this. So for that we will first consider the Z transform, the origin of Z transform. So origin of Z transform. For that, we first consider the Fourier transform, that is discrete time Fourier transform. So let us recall the definition of Fourier transform. X of omega is equal to summation, again limit minus infinity to infinity, x of n e raised to minus j omega n. It is the standard definition of Fourier transform in discrete time domain, that is x of n Fourier transform x of omega n equal to minus infinity to infinity e raised to minus j omega n. So as we consider the Fourier transform in omega, that is the e raised to j omega is the complex domain named as the y-axis represents the j omega and x-axis represents sigma. It is from the domain S, or it is also known as S-plane in Laplace term. So the Laplace is nothing but x of s is equal to summation n equal to minus infinity to infinity x of n e raised to minus st, where the s represents s is equal to sigma plus j omega. So s is equal to sigma plus j omega. It means each and every point, or a single point on S-plane represents this s is equal to sigma plus j omega. Means if you project j omega on y-axis and if you project sigma on x-axis, that combination becomes sigma plus j omega. For example, let us say the sigma is 2 and the j omega represents the j3. So the 2 plus j3 represents any point. Say the sigma is 2 over here and the j omega is j3 over here. So this point represents the 2 plus j3, the sigma plus j omega, s is equal to 2 plus j3. So here the remember point is this represents the S-plane Laplace domain, but our subject of interest is j omega. For example, let us consider the point S is equal to j omega. S equal to j omega is nothing but all the points on j omega axis. When we consider S is equal to j omega, we are considering all the points starting with plus infinity to minus infinity on j omega axis only. So it is S is equal to j omega. It is also means the sigma becomes 0 for all the value of s. So s is equal to sigma plus j omega, sigma is 0, so s becomes j omega. Or in other words, we can say the j omega axis has all the points where the sigma is 0. So in the equation of x of s, if we consider e raised to minus st, where the s is equal to j omega, this actually means it is the definition of discrete time Fourier transform. So in complex domain, or you can say S-plane or S domain, each and every point on j omega axis has the valid Fourier transform in discrete time, that is summation x of n e raised to minus j omega n, where e raised to minus j omega n represents the s is equal to j omega. So it is the another relationship between Laplace transform and discrete time Fourier transform, that is Fourier transform. And now we will consider what is the origin of Z transform. So as we discussed, the j omega axis is the subject of interest in S-plane. If we recall the Laplace transform, so j omega axis has again the second advantage of stability. It also comment on stability of LTI system that we discussed in chapter number 2 and 3. So LTI system is linear time invariant system. So the stability criteria based on this complex domain as per the Laplace transform is, if any pole on this plane strike the right hand side plane, it means right hand side of j omega axis, the each and every point on this plane, if it represents or if it representing the pole of S domain, then the LTA system is going to be unstable. Another one, if the pole is on the left hand side of the j omega axis, so the LTA system goes to stability, or you can say the LTA system becomes stable. So for j omega axis, or all the points on the j omega axis represents the LTA system to be marginally stable. So we cannot say exactly stable or unstable, so marginally stable. Now let us consider we are combining the plus infinity and minus infinity, because as we move towards the infinite side, say in minus infinite of j omega axis also and plus infinite of j omega axis. So for this purpose, if we combine the plus infinite range and minus infinite range in one circle, so it is known as the defining the complex domain in some another domain. Say we are just converting this straight line into a circle, so it is now a circular path on the same domain, on the same complex domain. So now it is having a linear combination or linear motion. We are converting into a circular motion with 0 to 2 pi, again 2 pi to 4 pi, 4 pi to 6 pi, and so on. So this will form a counter path on j omega axis, or below it is nothing but the conversion of j omega axis into a circle with a radius r. Or let us consider we are considering the distance of this circle with respect to origin is having r. So for that we should consider e raised to j omega, where j omega represents the complex points on this axis. Now it is converted into an angular point. So e raised to j omega we are designing as a e raised to j omega is equal to z. So now this equation becomes e raised to j omega we are replacing with z, but we cannot replace or we cannot alter this e raised to j omega. So what to do? So to give exact location of this all the points which are nothing but e raised to j omega, we should also consider that they are placed at a distance r. So now it is r e raised to j omega, which is equal to z, but we cannot multiply or we cannot alter the e raised to j omega with r. So we have to alter the input signal, that is, now we consider x of n is now multiplied with r raised to something, or let's say r raised to minus n. So each and every point on x of n is now multiplied with r raised to minus n. So then we can say it is the new domain of x of z. So now x of z becomes the summation n is equal to minus infinite to infinite x of n r raised to minus n and e raised to minus j omega n. So now considering the r raised to minus n and e raised to minus j omega n has the common power. Now that common power is known as x of n and r raised to 1 into e raised to j omega. If we separate it out, then it will become e raised to j omega raised to minus n. And we have considered r into e raised to j omega as a z. So this now will become the summation x of n z raised to minus n. So n is equal to, again the limit is same, minus infinite to plus infinite. So this is the origin of z transform, that j omega axis is now converted into a circular motion from 0 to 2 pi contour integration. That is, we are considering r e raised to j omega is equal to z, where the z points are placed at r distance from origin. It is representing all the points down as a z. So depending on this consideration, if we apply z concept in discrete time Fourier transform, say it eventually become the x of n z raised to minus n. So this is the definition of, or we can say it is the standard definition of z transform. X of z is equal to summation x of n z raised to minus n. So now hence we can prove that x of z is nothing but x of n z raised to minus n. But the most important question is why we require the x of z. However, we have DTFT, that is discrete time Fourier transform. So the e raised to j omega is our point of interest. It is the exponential term in our transform. So exponential term is now reduced to a simple term z. So this will become a mathematically ease, or we can say is a ease of mathematics. We can easily solve the transform domain, or we can easily convert the discrete time signal into a transform domain, or we can say in a frequency domain. So ease of mathematics is the main point, or is the main important parameter, or is the main important advantage of Z transform in a signals and systems. So now it will be x of z is equal to summation n equal to minus infinity to infinity x of n into z raised to minus n. So this is definition of Z transform. But again it is defined in some another way by considering, say, x of n is a causal sequence, or in other words, right-sided sequence. If x of n is causal sequence or right-sided sequence, at that time the x of z becomes summation, as it is right side, so summation limits to 0 to infinity x of n into z raised to minus n. So 0 to infinity right sided, and it is also known as the one-sided or single-sided Z transform. It is also known as single-sided Z transform, and it is also true for the another limit. So if the x of n is anti-causal sequence, for that, or it is known as left-sided sequence, the x of z becomes summation n equal to 0 to infinity is in a right sided, so minus 1 to minus infinity, or minus infinity to minus 1 is for left sided. X of n z raised to minus n is known as the Z transform for anti-causal sequence. So if we consider both the parts along with left side and right side, that is the actual definition of Z transform. It is also known as both sided Z transform. So it is the actual basic of Z transform. Z transform is nothing but transforming discrete time sequence into frequency domain using Z transform equation. X of Z is equal to summation n equal to minus infinity to infinity x of n z raised to minus n. Now let us discuss some example on Z transform, how to calculate or how to evaluate Z transform for a given sequence x of n.